Question 5. Lots of radians in here. So the first thing we need to do is find the area. Find the value of R. So we know the area of the sector is a half R squared theta when we're dealing with radians. And so we know that 40 equals a half R squared times by 2.4 times by 2.4, and so if we rearrange that, we'll get R squared is 80 over 2.4. So therefore R will equal 5.77 meters. So it's a good idea to mark that on the diagram. 5.77 meters here, 5.77 meters here. It's worth noting that this side and this side are not the same length. If it was a semicircle, then they would be. But because this side is straight, these are not the same length here. It tells us in the question that this side is 12. This whole length here is 12.5. So that means that this must be 6.25, and this must be 6.25 as well. Now we don't know what this is yet, but we have to do that in part B. So in part B, in order to find that angle theta, what we could do is we could do this big angle here, which is, it would be 180 degrees if we're in degrees, but it's pi radians, isn't it? So pi radians is 180 degrees. So in part B, we want to do those two thetas plus the 2.4. So this here is 2.4 radians, and so that will add to make pi radians. So rearranging that, we'll get theta equals 0.3. What does it say to round to? Just two decimal places. Okay. So theta is 0.37. Okay, part C. Find the total area of the stage. So we can find the area of the triangle and double it, and then add the area of the sector. That should work. So the triangle area is a half AB sine C, which is a half times 5.77 times by 6.25, and times that by sine 0.37. Try to keep your answers exact on your calculator, so just store them in the memory, and that will give you 6.5377. Again, write that down to a lot of decimal places or store it. And so our total area is going to be 40, which is the area of the sector, plus 2 of these. We need 2 of those because we've got 2 triangles, and so that should give 53.075. And what does it say? 1 decimal place. So 53.1 meters squared. And part D is saying the total perimeter this time. So let's just have a look. Let's have a look at this. Okay, so in part D, Total perimeter, well, we want to do this arc length here. That wasn't very good, was it? This arc length here, plus the 2 of these, and then we already know that this is 12, don't we? Okay, so let's do the arc length first of all. So that arc length is r theta, which is 5.77 times by 2.4, which is 13.856. Then we've got this triangle. So let's just use this triangle here. We've got 5.77. We've got 6.25. And we know this angle is 0.37 something. And we're trying to find that side there. So let's use the old cosine rule. Back from GCSE times. So x squared is going to equal 5.77 squared plus 6.25 squared minus 2 times 5.77, 6.25 times by cos, times by cos of 0.37. So just whack all that in your calculator, but make sure your calculator is in radians, and you should get x is 2.2653. So the total perimeter, we want the base 12 meters. Sorry, 12 point. Is it 12.5 or 12? Oh, it's 12.5. So this was wrong. That should say 12.5 meters. So 12.5 plus 2 of these. So we'll have 2 of those. 3.6. 2653. And what else we got? We've got the arc length up here. So 13.856. And add them all up, and hopefully you get a perimeter of 30.887, which rounds to 30.9 meters.